Welcome to this lightning lecture about using Entity Framework Core 2.1 with Xamarin.Forms. This lightning lecture assumes that you have some knowledge about Entity Framework. Doesn't necessarily have to be Entity Framework Core. Entity Framework 6 is also fine. Then you'll get the most out of this lightning lecture. My name is Rene. I'm a senior content developer working at Microsoft for Xamarin University. And you can find me on Twitter. You see my Twitter handle here. And of course, we have all the source code available on GitHub. That is the project that I'm using here. You can find it there, download it, and it has got all the packages pre-installed that you need in order to run this Xamarin.Forms app with Entity Framework Core. And now, without further delay, let's switch over to Visual Studio and have a look at all of this. Let me first show you which project type I'm using here. It's just File New, Cross-Platform Project, and then we're doing a Xamarin.Forms application. I just create one here quickly to show you what I'm exactly using. And this will be a master detail app. And the important bit is here that we base it on .NET Standard. So with that, switch over to the real app. This is what I'm using. This is what you also find on GitHub. You see, I can browse through the items here. I have this tab interface, which we're not interested in. I can select an item and go back. Now let's add Entity Framework into this. We right-click the solution, Manage NuGet Packages, and in the search box, we will be searching for the correct package. Just type that in here. And you will get many different matches, and there are different backends if you want. So you can store data in SQL Server, as you can see here. You can store it in memory for testing, or you can go with SQLite, and this is what we will use here. So let's go ahead and select the SQLite one and make sure that we install this in all of our projects. So there we go. Let's just click install, and it's gonna run. Takes forever. We fast forward here. We have to agree to the license, and then it installs a bit more. And if you want to read about what we can do or what you can do with Entity Framework, check out the documentation. You'll find the link in the repo. So this should give you an idea in here. You can create indexes, you can seed data, you can of course create, update, delete. You can create foreign keys, you can migrate data. It's all in there. I'm just going to show you the basic concepts to get this run in this app here. So we first start by adding a repository, and that is our entry into the world of Entity Framework. I'm just going to call that repo. It's a regular class, and if you have ever worked with Entity Framework, you know how this is working. You derive from a class that is called DB context. And that DB context class, it is something where you provide information about what kind of, entities you're working with. And in our case here, the template that we used, it provides already an item class. So we want to use that item type here as our entity. That means we're going to create a DB set. The DB set is the representation of these entities. Now we call it items. And then we need to add accessors so we can save data into our items table. That will eventually be what gets created. So this property will be turned into a table. If you've ever used SQLite.NET, same principle. You would have an entity type and then you map it to a SQL table. Now in order to configure everything and set it up, we override the onConfiguring method in here, and we find that the options builder has got an extension method that is called useSQLite. In order to specify the database that should be used, you simply have to know how to do that. It's file name equals and then database path. There are other variations that I did not check out. You can also specify a data source. Now, since our Xamarin.Forms project is running on multiple platforms, that's Android, iOS, UWP, we have to take care of the platform-specific paths. So let's initialize our repo with a parameter that we simply call db path, and we store this locally and can then use it in the onConfiguring method. And later we will have to take care of passing that path from the platform specific projects into our forms project and then pass it further on to this repository. Let's switch over, and the file that we are selecting here, that will be our app.xaml.cs file, and in there I'm simply going to add a static accessor in order to get to the repository. You could use something like dependency service, but we want to keep things simple here. I'll leave that up to you as extra bonus work to make a better implementation. We just go with a public static repo, we call it repository, and resolve that really quick here. And then in the constructor we want to initialize that. Now, in order to initialize that, remember, we need the database path. So here it is. And we pass that on to the repository, but of course we have to get it from somewhere. So let's add another parameter, this time to our applications constructor. Because the application is generated on a per platform basis, we just search for all the references and we pass the database path and from the projects over to the application constructor, and that means it's going to end up in our forms project and eventually in the repository file that is used to access the database that is maintained by Entity Framework. Here on Android, we can simply put the database into the My Documents folder. There's no specific rules on Android. You can place the file in there and nobody's going to complain. It's a bit more difficult on iOS. We'll see that in a bit if we switch over there. It all starts with the same folder with My Documents. However, from there we go one level up and then we go another level down, and that subfolder is called Library. And Apple says if you are creating or if you are using a database in your application, it must be stored in a subfolder under Library. And that's exactly what we're doing here. Now the problem is we can get that path. You see, I'm using path.combine and get folder path here. We could just pass this over there to our applications constructor. However, there's of course no guarantee that the subfolder that I'm using here on the library really exists. So that's why I'm splitting the path up once more, and I add a check in here that says, does this data subfolder, that's just the name I used here, does that exist on the library? And if not, well then let's create it right now and then append the database file name to that just created path. And that's what we then pass over to the Xamarin.Forms application. That's why we have a bit more code here in iOS. And this is really a reason for rejection. So believe it or not, if Apple finds out that you are placing a database file, let's say in the personal documents folder, they might reject your app. And of course, we want to prevent that. That's why we're going the extra mile here. Still have to fix the typo in here. And then we're ready to go. Just create that directory. And in a second, we will be in our UWP project. So there's UWP. And in UWP, well, completely different API. There we're using application data.current. And then we find a property that represents the storage area that we can use. That's the local folder, and we get a path property, and we just combine that again with our database name, which I'm calling database.sqlite. Of course, you can pick whatever name you prefer here. And in order to verify or check where this is getting stored, I'm always adding a bit of logging in here, debug output, and I'm outputting the database path and file name in there. And later, towards the end of this lightning lecture, we will be able to access the generated SQLite database in the case of iOS. Of course, you can access it on the other platforms too, but with iOS it's just super easy and we can verify what is in there and have a look into it. And that brings us back to our item. So whenever you use an object relational mapper like Entity Framework, also like SQLite.net, then you might be used to something like this. You just add these attributes here to the fields or to the properties that you have inside your entity type. And we got to resolve them here. So we say this one is a primary key and the other one is required, and maybe another one has got a max or a min length or whatever. The problem with that is that by adding these attributes, suddenly your entity becomes dependent on system.component model. And maybe you don't want that. Maybe you want to keep your type here clean and not have it cluttered with this extra information. And Entity Framework Core supports that, which is really nice. They have added an amazing Fluent API, which we are using now in order to add these attribute information on the fly. To do that, we are overriding on model creating, and we're getting a model builder. And this model builder, we can now tell, hey, have a look at our entity, which is an item type, and inspect the property text. And we always want to require that text property. And this is exactly the same as if we had added the required attribute directly here into my item type. But now my item class is completely clean. It's just a simple C# object with a bunch of properties. We can of course do more in here. So let's just make a primary key in there. So again, use the model builder. We say we are talking to the item entity, and then there is a hasKey method, and we just tell it which of the properties is going to be our key. Super simple. But it doesn't end there. So just for the sake of demonstration, let me show you something else. Let's say you wanted a combined primary key, something that consisted of two fields. I'm just adding a dummy here, just another property that I want to include into the primary key. I can just go ahead and turn this here into an object and then specify a list of all the properties I want to use. So just add a new operator and boom. Now my primary key is a combined key. That's super easy. And you can just do all of this with this Fluent API. Now let's remove it, because in our case, our item type does not have a combined primary key. It's just a simple string here. We're going to clean that up. And then, we want to add something in here, make it a bit more difficult. You know, often it can be a bit challenging to store certain data types. I mean, as long as you have an integer field, obviously it will end up as an integer in the database. But what if you have an enumeration? How are you going to store that? You know, an enumeration is really just an integer, but you could also store it as a string. Now, you can instruct Entity Framework to convert types. And to show you that, I just add an item category in here, and I put a property inside my item type. And I'm going to call this category. And I want this to be stored as a string. So if the value is shopping, I want to store the string shopping and not the integer value that would be 0. And in order to achieve that, we can add a value converter. And again, these value converters are super easy to set up. We just go back to our onModelCreating method and then configure the converter. And I'm going to show you this here. The example will be something that converts our category, which is really integer, into a string. So you know how this goes by now. We just use our model builder. We point it to the entity type, which is our item. And then we refer to the property. That will be our category property. And we use the hasConversion in there. hasConversion then takes two parameters. And the first parameter, that's the conversion that's going to happen if our data is being moved into the database. So here we say we receive this enum and we turn it into a string. And when coming back from database, we have to take care of the conversion the other way around. So we got to do some magic here to convert that string back into our item category enumeration. That's just doing enum.parse, passing in the type, etc. So this is how you would add a value converter for storing types. Super easy to do. Because what we have just done here is so common, by that I mean that you want to store an enum as a string, it is already built in. So you can just use what is already there. We just create a new converter that turns enums into strings. New that up, we're going to resolve it. It's part of the Entity Framework core namespace, and we're done. If you want to know what converters are built in, you can check out the documentation. There's quite a few really useful ones, and it's of course even easier to use those built-in converters than writing your own. Now off to some initialization data. After all, we want to have something in our database when we start the app, and of course this seeding process is also supported with Entity Framework Core. It's a bit different from what you might know comparing to Entity Framework 6. So here it's directly part of the derived DB context, and it again starts with the model builder. We just refer to our items here, our entity, and there's a has data method. And has data just takes, well, an arbitrary amount of parameters, and we initialize our items here with the data that is already existing and that was generated by the template. We find this in the view model here. I just copy that over and pass it in here, replicate the behavior that we have with the custom implementation that we want to replace with Entity Framework. And I'm adding the additional property that we have in here now, our category. And since I have only created 3 categories, I am simply going to remove the other 3 item types here and give those 3 here meaningful descriptions. And that's it. Now, this would only run if you have the correct call. For testing, you would just use the ensure create database. That will make sure that there's always a new database, and you put that into the constructor. And then we're finally at this point where we can implement our get, read, update, and delete methods. And we start with get item async and find an item based on ID. Very easy to implement. Just use this items property, which is our DB set, and then we use link. And these link queries, they will be translated into database queries, but we don't have to worry about that. We just say we need the first item that matches the ID that we're looking for. And of course, we can use configure await false here to make this a bit more performant and avoid the unnecessary context switch, and then return the item. Boom, done. So you see, this is a no-brainer. Really, really easy to do. Now the next one that we have in here is a way to get all of the items. And again, similar, if you wonder about the signature here, you see it's using this force refresh, which is by default false. We'll get back to that later. In fact, I'm completely ignoring it here. So how do we do that? Well, just use our items, our DB set, and call toList async. This is going to read everything from database, so be careful with that. You're going to end up with all of the items in memory. You only want to do this if you know that there aren't too many items. And add async here to make the compiler happy, and that's it. So now we can get a single item, we can get all items, and if you're a fan of C#7, you can of course turn this into an expression bodied method. I'm just adding this here to show that you can further reduce verbosity, and then it would just look like that. Same functionality as the method above, but I'm just going to keep it as it is. So getting is one thing. Well, now we gotta think about the next one, and that would be adding something. We can add an item, just gonna change that here, make it again async. And you see how our Entity Framework Core has all these nice asynchronous methods built in. And we just call items.addAsync and pass in the item. That's it. And once again, I'm simplifying a bit here. I'm just returning true here. So this method is supposed to return true if everything's okay, and otherwise false. And I'll just leave the error handling up to you and figure that out. Then we have the next one, which is update. And for update, well, we're updating an existing item. You can just change properties of an item and write it back into Entity Framework. We simply call our items.update and pass in the item. That's it. It will know which item to update. The important bit here is that when we have updated an item, eventually we will have to save. And you notice I forgot this save call up there at the add item async. So you will find that in the completed repository, of course. So it's up to you when you save. You don't have to do it after each and every item, but that's what we're doing here. So we can get something, we can update. Next, we want to be able to delete. And no big surprise here. There's a remove method inside our DB set. We can use that. However, we need to find the item to remove. So this delete method here is based on ID parameter. That means we first have to query and see if there is an item that matches this ID. And if it's there, if it's not null, then we can remove it. And once again, we immediately save. You could defer that save call to a later point in time. That's up to you. And again, simplifying error handling here. This should return true if, I guess this should return true if something was deleted, otherwise false. And again, if you wonder where these method signatures are coming from, you'll find this iDataStore interface here that is generated by the template. And that's where I took all the methods from. And the reason is that there is already a mock data store part of the project that implements iDataStore, because we perfectly matched the methods in there. We can just take this iDataStore interface now and add it to our repository class. And that means our Entity Framework repository is now an iDataStore. Now, why is that a big advantage? Well, you see that in a bit. Let's just mark the interface region in here. I always like to make it clear what we're looking at here. So just put a region around that. And of course, don't forget the end region. And then we switch over and see where our iDataStore is used. We can simply find that by right-clicking iDataStore. And we can see that it's initialized here. You see it's using a dependency service. If it can't find it, it's using the new mock data store instance. I'm simply going to remove all of this here and just assign our app.repository in there, because app.repository is an iDataStore. We just made it one. So by doing this, we are able to deploy this to the platforms and it will work. That's all you have to do. Here we see UWP in action. We have our seeded items. We can change them. And once they're changed, we can of course save them and they will be stored back into the database. Just find the menu, save, and you see the item has been updated here. What we're missing is the category. Let's quickly add that. I go into the corresponding XAML page in here, which is in the views folder, and there's a details page in there. We can change, just go in the XAML. And the template here is really well done. It's using data binding. That means we simply add another label in here and we bind to the category. And we want to see if the category is retrieved correctly, if it's going to show up as a string. We put this converter in there, so it should be stored as a string. Of course, it should always be received as one. Let's run this again. Select that, and indeed we get our category. This one is work, and the other one here is shopping, and the first one, that would be, I guess, private. Now here's Android. Quickly build that. Of course, same functionality. I can edit an item. Make this here an Android item. Save it, and it appears there. So no big surprise, it's a Forms app. Of course it works cross-platform. Now let's try iOS last year, run that on an iPhone 10. And yes, I fast forwarded here. And what you see here, if you run it on iOS, is this error. Now, this is expected. Entity Framework relies on a wrapper around SQLite, and you need to call an initialize method. And we're going to add this into the app delegate of the iOS project. You can also find a reference to that in the documentation. You just call this init method in here. And in order to prove that it's really all working, I'm now deleting the app from the simulator. So it's really completely gone, and I clean the solution. Because otherwise, it's that was a bit surprising to me. If you run the app again, it will work even if you do not have that call for some reason. I don't know why. So I just wanted to make sure that everything's gone. We reinstall. Now the init call is in. And when the simulator has started the app, we can use Entity Framework Core on iOS. Now let's add one. We call this our iOS item. And when it's saved, we want to verify that it's really stored in the database. Remember, we put this debug write line in there that's showing us the database path. Now you can copy that database path and then switch over to the Mac and open it there in Finder. And if you have the correct app installed, the one that I am using is called Base, then you can inspect the contents. You see, we simply go to library, there's our data folder, and there's database.sqlite. And indeed, we find an items table with all the expected columns. I can select data, I can reload data, and I see all of my data in there, correctly stored in a SQLite database, and our enumeration is stored as a string. That's it. Isn't that easy to use Entity Framework Core? I like it. I hope you like it too. If you have any comments, please be sure to use our forums, or you can find me on Twitter. That's Rene_Ruppert. Thanks for watching, and bye.